Exercise 3. So Mr. Armstrong is putting a shot and the ball's trajectory, let's see where we are, here we are, can be described by the function f of x, so it's a function of the second degree because we'll look at the x2 term here. And it's a negative x2 term, so it's going to be something that looks like u upside down, like a hill. Where x is the distance in meters and f of x is the height above ground. Okay, so first of all, what they would like to say is that this function is describing the ball when it travels through the air. Okay, so when he just is putting a shot here and then it starts to travel through the air and then eventually hits the ground. This kind of path can be described with this function. So how about we just have a look at this function to start with and see how it looks like, and then we'll go back and analyze and see if we can try to understand what they're asking for. So this is a fraction x squared divided by 35, and then minus plus 16x over 35, and then over 35. Now you can do like this. Let's see, select this and then do, if you forgot to kind of make it into fraction, and then also divided by 35, and then it was plus 1.67. Was that correct? Yes. So let's have a look at this function. This is our function. I'm going to move this one up here. I'm going to zoom out one so I see actually what's happening down here and to the right. So menu, zoom out around here, and then I can actually do a box zoom, so I just zoom in on the important part of the curve, because on the x-axis here, if we start at the origin, this is where Mr. Armstrong is standing, and y, or f of x, which is the same thing, is the height above the ground. So x-axis, this is the ground. This is the ground level, the x-axis. So the ball is here against his right shoulder, as we can see in the picture. And then it will travel through the air from here up in the air and eventually hit the ground somewhere over here. Okay, so x is the distance it has traveled. So then they're going to measure from where he's standing. X is 0, x is 1 meter, 2 meter, 3 meters. X is in meters. So here's where it's going to hit the ground, and they have to measure how far it flew. And then the height above the ground is the y-axis, also in meters. So let's go back to the question and see if we can understand the question. How tall is Mr. Armstrong? Okay, so the distance from his right shoulder to the top of his head is 28 centimeters. So from here up to the top of his head, here it's 28 centimeters. So the ball is located at the y-intercept. So where is that? Well, we can just look at the function and see, well, f1 of 0. So this is going to be 0, this is going to be 0, and this is left. So 1.67, that's the y-intercept. So 1.67 meters, that's where the ball is located. and then we have to add 28 centimeters, because that's the distance from ball to the top of his head. Then we will have Mr. Armstrong's body height. Okay, so if we really want to be sure to find the y-intercept, if we don't trust this method, we're just gonna open up a calculator page, and as we know, when we define it in a graphs page, we can just enter f1 of x, and the function is already defined there. So f1 of, when x is 0, that's where we get the y-intercept, which is 1.67. So on question A, we get 1.67 meters plus, and then in meters it was 0.28 meters, which is the same as 28 centimeters. And then if we add it up, 1.8095, 1.95 meters, and then we would write something. Mr. Armstrong is 1.95 meters tall, or something like that. Then we can also mention how we got the 1.67. F of 0 is 1.67, and within bracket, that's the y-intercept. Okay. Intercept. Okay. Question B. What is the slope of the tangent to the curve of f of x at x is equal to 0? So we once again look at the graph. Here, around here, actually where x is exactly 0, there's going to be a tangent, which is more or less something like this. What's the slope of this tangent to the curve where x is 0? Well, since this is a calculator exercise, we're just going to go to geometry and plot some point on the graph. And click here. I'm actually not going to plot it at 0, just to show you, excuse me, in case that you didn't get it exactly right. You can actually just put the point here, then you see it's 1.18. I'm just going to click escape to go out of this plotting the point mode. And I can maybe move the coordinates up here. I'm just going to click once over the x-coordinate, click again, and then I can just delete that and put 0. And the point is going to move on the curve. And now we see the coordinates for this point. And the second step would be just to go points and lines and then choose the tangent. Click here and automatically we get, we get the equation. So let's see if I can move this up here. So the slope of the tangent is this value in front of the x, right? So 0.46 says something about the slope of this line, of this tangent. So slope is 0.46. And I would like you to actually write some proper answers. It's a little bit difficult with this pad, so I'm just explaining the method and showing you how to get the answer. So that's the slope, 0.46. C question, how far does he put the shot? Okay, so where does it hit the ground? Remember, he's standing here at x is 0, and then it travels. We're not talking about the path it travels here, it's the distance from where he's standing until it hits the ground. So what is this specific point called in calculus? Well, it's the 0 of the function. So we just analyze the graph and we find the 0, and we go a little bit to the left and then click, and then a little bit to the right and click, and then we see that it's 19.1. That's the x-coordinate, which is this direction horizontally. So the answer on C is 19.1 meter. And then on D, what is the height above the ground of the ball when it is at its highest? Okay, so if we look again at the curve here, that's going to be the highest point. How high above the ground is the ball? Well, in calculus, that's called the maximum. We're going to get the maximum, go a little bit to the left of the maximum, to the right, and now you see it locked in on this particular point. Now, are we going to answer 8 or 3.5? Remember, x is the 8 is the x coordinate, that's the first coordinate, so that means that the distance from here to here is 8 meters, but they want to know the height above the ground, so it's from 0 up to 3.5 meters. So we're going to answer with the y coordinate. The highest point above the ground happens after 8 meters, and it's 3.5 meters above the ground.